Hey guys, what's up? It's Chris, founder of Finxter.com, and in today's video you're going to learn about Python's frozen sets. So actually there are like 5-6 main Python data structures, and most Python coders know them. But frozen set is an exception. So most Python coders, I have never seen like intermediate level Python coders use a frozen set, and even advanced coders, they know it exists, but they never use it. So in this guide, you will learn about Python's built-in data type and built-in function frozen set. So how to create a frozen set, what it is, and like what is the difference to other data structures. Okay, so Python's built-in function frozen set, it creates a new frozen set. You can pass one argument, an iterable, into the frozen set, and it will simply create a new frozen set for you. So I will show you in a moment. And then practical code examples. So let's remove all these things and run a new code snippet. So I think it always makes sense to slowly show things in the Python shell. So you see a frozen set, it's already highlighted. So therefore it means it's a built-in Python function. You don't have to import anything to use frozen set in Python per default. And then you pass one iterable. So you can also pass nothing. Then you will create an empty frozen set. But we will see in a moment why this doesn't make sense in most instances. So otherwise you can create a frozen set like of numbers, or frozen set of strings, Bob, and say n. So we have 3 values. We pass an iterable into it like a list. It could also be a tuple, it could be another set, it could be another frozen set, it could be a dictionary or so. So you pass an iterable of elements, and then it creates a frozen set out of it. So what is a frozen set? A frozen set is just like a set, but an immutable one. Okay, so sets, if you create a set, for example, say we use this same data structure here, and we create a set called S. So S equals set S. Okay, so now if we print S, you see it's a set data structure. You see it with this curly braces and brackets. And now you can, for example, add an element. Like say we add Carl to the set, and now the set also contains Carl. We can also remove, say, N from the set. And now if you print the set, it contains Carl instead of N. Okay, so you can do these operations on a set. So this means that sets are mutable, so they can be changed, but frozen sets cannot be changed. Okay, so let's initialize S as a frozen set of what was S before. So now if you print S, you see it's indicated with this frozen set environment, and we have a set within the frozen set environment. So this is just a string representation of a frozen set in Python, and it contains the same element. So if you would compare it against this set, it would actually result in a true Boolean value because they contain the same element. But you cannot change a frozen set, so you cannot call s.add, for example, say we cannot add n again to the set. Then it will just throw an exception. It does not have an attribute add. And you also cannot remove some elements, like for example Alice, from the frozen set. It would also throw an exception. Okay, so frozen sets are immutable. You cannot change it. But you can do a lot of the other set operations. Like for example, you can do, like if you have frozen set A, and say this contains of the value 1, 2, 3, and you have frozen set B, it contains of the values 2, 3, 4. You can check, like you can do, for example, A.union B, and this creates a new frozen set with the union of both elements. Okay, so we have now elements 1, 2, 3 and 2, 3, 4. So we add all of them together in a union. So creating a new frozen set with all the values 1, 2, 3, 4. Okay, or you can also do like intersection of A and B, which is just the two values 2 and 3. Those values are in both sets. So you can perform all sets operations. You can check disjoint operation and so on. So you can use all set operations, but with an exception, you cannot use those set operations that would modify an existing set. Why? Because frozen sets are immutable. They cannot be changed. And the advantage is of a frozen set compared to a set that it's a bit more efficient because it cannot be changed, so therefore we can do some optimizations. But I think the most important example is that sometimes you have a set and you don't want to you don't want to allow that people can change the set, or your coders can change the set. For example, you pass a set. If you would pass a set into as an argument into a function, this function may actually change the set. So, but what if this set is like, it's a set of your customers or so, and you don't want to change it, you just want to give them information about your customers. If you wouldn't use a frozen set, you would have to create a copy of the set and pass a copy of the set, which can be really inefficient. But if you, like with a frozen set, you can simply pass a frozen set and you can be sure that it won't be changed, okay? So you can use this frozen set, this immutable set, as an input for many functions, and even if you don't know what those people are doing with the functions, you can still like allow them to do anything, because they cannot change it. It's an immutable data structure, so you can be sure that your frozen set won't be affected by it. So I think it's a good way of defensive programming, to use frozen set instead of sets if you don't want to change the sets, actually, if you just want to use this as a basis. Because then, I mean, even if you wanted to do something nasty with the sets as a coder, or I mean, sometimes you just write code that is buggy, so you accidentally change a set. This could result in bugs that are very hard to find, and that are very costly in the end, because you may search for those bugs for weeks or so. I mean, I have searched for bugs that are far easier to find, and it took me like many days finding those bugs in my practical code project. So if you could avoid these type of mistakes by using data structures that don't provide more than you actually want them to, then this is called defensive programming. You can reduce the number of bugs in your code and